Okay. Well, thank you for picking this presentation. Sorry about the microphone. I'm really excited about the way we run end-to-end web tests at Mercari US. We literally run thousands of them. I'm Gleb Bahmutov, so I'm going to show how we do it, how we use AI, how we organize which tests to run. And I do have a GitHub profile and YouTube channel and blog because I forget how to do things if I don't write them down immediately. So it's very frustrating for me to know something that I know how to do, I just forgotten, right? I've done it. So I write everything down, and a lot of my communication with my fellow engineers is just like sending links to my blog posts or videos. So if you want to see how I've done things, everything that I'm showing today was described in blog posts. I work at Mercari US, Mercari.com, online marketplace. If you don't use something, it's easy to sell and buy. And this is a typical end-to-end Cypress Mercari web test. What you see is a browser recording. That's a real browser like Chrome or Firefox. The website is iframed on the right side, and all the test commands that are running are reflected in a column on the left. And our test literally clicks on buttons, checks the text, confirms that in this case seller and buyer can message each other. This is a full end-to-end test that exercises all stack from the front end all the way to microservices and back end between two users. We do pick end-to-end as main way of testing because the unit test is focused on the code, on piece of function, a piece of class, right? It's fast, but it only confirms that this particular piece of code works. We do have API tests, obviously. Each team that creates a microservice, they write their own API test. But you know what? I think the users don't care. They only care if they can go to Mercari.com, if they can click on a button, they can send a message. So the only real test that the user cares, that gives us any kind of confidence that all thousands of moving parts work together is end-to-end. And the unit tests are usually fast by default, right? It's hard to write a unit test that's slow. The end-to-end tests are usually considered flaky and slow, but they don't have to be slow. And I'll show some of the techniques that we use. They can be fast. This is how many tests we have over the past year. As you can see, it's well above 1,000. It kind of grew over 4 years. We allow the QA automation group to write tests. We allow the front-end team to write tests and update tests. And we add new tests as we develop new features. This is a typical code. It's JavaScript. This test, for example, clicks on its home address, and it should be checked, and then it clicks on the Save button. A couple of things to notice is that we use VS Code or cursor, and in this case, the inline code suggestions are actually very, very on point. So I do provide a lot of comments and context so that my copilot in VS Code helps me code faster. We also use test tags. So we tag each test broadly by categories. If this test is related to a help center and related to a search. We use abstractions like page objects so that we don't create giant, hard to maintain tests. Instead, we have high level, in this case, like visit and loaded page abstractions. We use data test IDs to access elements. It's pretty uniform, but allows us to perform like interesting things, including picking the tests to run. It's pretty standard for us to, if you see data test ID attribute on an element, that's an attribute that will be used for end-to-end testing. How do we make end-to-end tests fast? Well, first of all, we don't use UI as much. Of course, we have a test to sign a user, right, or log in with a user profile. But all tests that go beyond that, right, for example, for messaging between seller and buyer, they don't go and use the UI to sign up a user. They use API calls that are very fast. Anytime we create data like a user profile, we cache it so that we can reuse it as many times as necessary. And this speeds up both CI and writing the test as the test reruns. It kind of doesn't have to recreate all the data all the time. And we don't hardcode waits. I mean, sometimes you have to wait maybe a second or two, but we never let the or we never force the test runner to say like sleep for 30 seconds and then continue. We always do intelligent waiting, wait for some attribute, wait for some event, wait for the data to be available. And the test speed for our end-to-end test could be anywhere from 1 second to 4 minutes. If it's longer than 4 minutes, then something is wrong, and I probably will split it up. Still means that if you have 1,000 tests and each one is a couple of minutes, then you cannot run them on every commit. It's just too many tests to run. So instead, we run all the tests every 8 hours. And we parallelize them. We use a Cypress dashboard. It doesn't really matter the approach, but it does intelligently orchestrate which machine executes which test, and it uses previous test duration to optimize it. As you can see by the width of a rectangle, that's the timing. So the longer test will be executed first. And this ensures that the overall organization is optimal, and there is not a machine that suddenly got a very long test at the very end and you sit there waiting for it. In this case, it took less than 40 minutes to run all the tests across 20 machines, but 20 is just a parameter. The only thing that really controls the speed of end-to-end tests for us is how stable is dev environment. Can it handle 100 parallel test runs at once? If it can, we can parallelize it and add more machines by just changing the workflow. But the question that I want to say or answer is, do we need to run all the tests, right? If they're too slow to run and you only run them periodically, maybe you don't need to run all of them. And we rely heavily on feature-specific testing because you don't work on everything at once, right? You're probably working on a specific feature. For example, I'm working on item search. What tests do we have for the search itself, right? If someone says that the search is not working on a specific page or returns weird results, well, you want to look at all the tests for that particular feature as well. You're not looking at everything. If a user reports a bug, you usually know the details. You don't say, user reported a bug, well, I have to run all the tests, right? And if you're working on a particular PR, even if it's not front-end related, it could be maybe a back-end PR, it's still probably related to some particular feature that maps to some particular test tag. And this is why these tags are extremely important because they're easy to search, easy to use. We use feature tags like search, help center, profile, cell, account. So these are feature tags, but we also use different types of tags that we kind of call group tags. So for example, sanity would be an example. If feature tags are on top, each column shows a little bit like each test. So there could be different number of tests for each feature. And for example, a tag like sanity cuts across all the features. We tag a couple of like representative tests for each feature, and they constitute sanity set. If someone is working on tests, for example, or front end, when we open a PR, they can tag using checkboxes in a pull request text template which test you want to run right away. So on the top, I tagged run all the test tag sanity, and I checked the box that says run test tag search. So really crude, kind of general. You don't have to be extremely specific. Just run more tests what you think you should, and you'll be okay, right? Just don't run them all. If someone opens a PR, for example, for our front end, well, we don't want to give them like thousands of checkboxes, right? Because things change, it's their repository. So instead, we do a different thing. We automatically comment on a pull request with some helpful information. For example, once we deploy, we give you a URL for your preview environment. We also tell you, okay, if you want to run Cypress tests for this particular PR, you can run them all, Cypress all, and we warn that this is slow, right? And it could actually overwhelm your PR preview environment, so it might actually struggle to keep up. We also say you can run Cypress tests with particular tags using Cypress tags command. So we give the developer kind of information of what to do and how to run the tests. In this example, a developer ran tests tagged sanity and profile. We don't add @ symbol because on GitHub it actually has a meaning, so we allow you to just put tags without any ampersand. So in this case, 115 tests were specs were tagged sanity or profile, and they would execute. In our repos, we're not front end, but back end and microservice APIs. We also comment automatically, and we allow backend developers to run end-to-end tests against their PRs. And again, we post a helpful comment right away. For us, it's all about not running all the tests, but giving you flexibility to run the test that you need. So like I said, you can select test using test tag. We also keep track of which pages each test, end-to-end test visits. And you can pick tests that, for example, visit your purchases in progress page. And we also communicate with the backend using GraphQL with operation names, and we keep track of which operations, which test actually executes while it's doing its job, so that you can run tests that only, for example, make this call like new lister. Okay, it's another way for us to select tests that are relevant to your change. Even better, we allow you to specifically pick tests based on your code changes. Again, because we use data test IDs for picking tests, if a user modifies a file and this source file has an element with data test ID greeting, what we can do is automatically find all the spec files and all the tests, but use that test ID. And that allows you to focus and run the test specific to the pages you just modify. It's crude, but it works, and it's very fast. This is another example. Again, the same run Cypress tags sanity profile, and it found that these files were modified menu items component, and it picked one logged out spec that touched those components. One thing that people are never sure because they are not responsible for writing test tags is like which test tags do exist and which ones are relevant to their change, and I want to help them. So one thing is AI. So imagine this is actual real PR, and the developer in this case, all we've done was to write the subject line, and they left the pull request text blank, and they said shipper improvements with clean commit history. Now, you probably don't know what, you might know what shipper is. You might assume clean commit history is just very generic, but you have no idea which test tags are relevant to this particular service. You can guess what shipper means, but we have, again, command that you can use in your comment on a pull request, like what says web test tag, and it will use AI and text match to just say, okay, out of this pull request, text and subject line, what is the closest test tag that matches? And of course, we have descriptions for each test tag. So in this case, it found that 2 test tags are appropriate, shipping, and regression. And shipper is our shipping service name, a third-party name. So shipping does seem to be correct. And regression, I guess it recommends also to add more regression tests. Even gives us confidence, so we can kind of look. If we really disagree, we can see why and what was the confidence for that suggestion. And if you receive a bug report, you can do the same thing, because now you have a bug report where, for example, if someone says cannot transfer money, it can automatically find all the tests related. In this case, balance and payment are 2 tags that do seem to be relevant to the user cannot transfer money. And we can execute them all automatically. So even before someone starts looking at the bug, we can give them a lot more information and run all the tests for that particular bug. Finally, we use Copilot pull request reviews. In addition to all the linters and all the standard stuff, you can write Copilot instruction file. But for example, if we use data test IDs, well, we want to have data test IDs for every piece of information that shows something specific, like price, maybe shipping method, and so on. So we do have in our Copilot instructions something like check HTML element to have a data test ID to be used in end-to-end tests. And if we try to sneak in some changes in front-end code, it can look and say, okay, well, you're showing a price or a name, and you don't have data test IDs. Even suggest, based on the component name, a data test ID to add. So here's what we learned, and this is kind of our conclusion. A lot of people are trying to use AI systems to generate code, and I think it's difficult for many, many reasons. For me, it works pretty well in small Copilot code suggestions, especially if I have good variables, good comments, and so on. Big generation, you need all the context. You need domain knowledge. And you have to wait, usually. And you have to pay money. And with long waiting loops where you kind of fire it off, do something else, fire it off, and when you come back, I think it's hard, right? Because it's context switching, and it's reviewing a lot of AI-generated code. And I don't like it. I don't even like reviewing human-generated code. And so human review is hard for AI code, I think. Now, using Copilot instructions so it can review our code and give some suggestions is actually easier problem, right? It can look, it never gets tired. It can review and find missing data test IDs, okay? It can explain maybe things, right? So I find that code review in Copilot actually is pretty useful. And even if it messes up, just like me reading someone else's review, I just ignore it. Like, it doesn't have to be 100% correct to be useful. Finally, picking one out of multiple possibilities based on text, right? Like, which test tag is appropriate for this pull request, subject, and text. I think that works very, very well, right? Because large language models, by definition, should understand which text is closest to which other text. Like, if they don't work for that, like, what are we doing, right? It's a language model. It's supposed to pick one out of possible choices. So I think it works pretty well. If I haven't convinced you that end-to-end testing is extremely important, well, we have to chat some more, because to me, this is what actually makes user going to your website and trying to purchase an item most likely to succeed. If an end-to-end test that did it passes, then the user probably is successful, you can do that. Trying to just brute force it and say, we're gonna run thousands of tests. I don't think it can be hard to maintain, right? And end-to-end tests, by definition, they need the whole system. So it's expensive, and it can be overwhelming if you run lots of tests in parallel on your dev environment or your web pull request environment. So you don't have to run them all at all times. You can pick when to run them all. And AI can help. It doesn't replace you. It will not, how should I say this? It will not replace you so you lose your job. No, I think AI is just a tool, and using the right tool for the right task, I think, is a good thing. Well, thank you so much. I'll put the slides somewhere if you want to follow me or connect gleb.dev. You've been a wonderful audience, and I'll answer any questions in the speaker Q&A area. Okay, thank you.
グレブさん、ありがとうございました。